Let's talk for a minute about solving exponential equations that cannot be written with the same base. This is a continuation from the previous video we did. So if you remember, last time we solved exponential equations, we had something maybe like this. 2 to the x minus 2 equals 8, and we were asked to solve for x. And what was terrific about this is we could write both sides with a base 2. So we could write 2 to the x minus 2 equals 3, let's say. And since they're both base 2's, the only way that can be equal is if the exponents are equal to each other. So we can just say x minus 2 equals 3, which means x equals 5. Now, here's our issue. We're going to solve equations like 2 to the x minus 2 equals 7. And the problem here is that there is absolutely no way that we can write both 2 and 7 with the same base like we did in the last time. So here's what we're going to do. We're going to use some of our properties of logarithms, like especially the fact that when you have the log of x to an exponent, you can move the exponent in front of that logarithm. So log base b of x to the n is equal to n times log base b of x. So we can take exponents and move them in front of logarithms. That'd be terrific to do with this exponent up here. The only problem is we don't have a logarithm. So here is the main idea. We're going to use the rule for the exponents with the logarithms, and we're going to take the log of both sides of our equation. The terrific thing here is that it doesn't matter what base we use. So a lot of times people will take the base 2 or the base 7 because they occur in the problem. Most calculators don't have log base 2 or log base 7, so I'm going to take either log base 10 or log base e. In other words, either an ln or log. So for this one, because I'm low on room, I'm going to take the ln of both sides of my equation. And when I do that, I'm careful to write the ln or the logarithm on the left portion of that side of the equation that I'm taking. I would never write 7 ln. Completely meaningless. So always write the logarithm or the ln on the left. Now, the whole point of that is now we can use that logarithm rule. We can take our exponent and move it down in front because now we do have a logarithm. So since I have subtraction there, I'm going to write quantity x minus 2 times ln of 2 equals ln of 7. Okay, so again, what I did, take the logarithm of both sides. It doesn't matter which base you pick. Move your exponent now down in front because now you can, since you have a logarithm, now you can use this rule. And then the second thing that we're going to do is solve for x. Okay, so let's see. Since x is inside the parentheses here, I have two choices. I can distribute the ln through, or a little bit faster, if we simply divide both sides by ln of 2. Now the ln of 2's cancel. ln of 7 divided by ln of 2 does not cancel, but the ln of 2's do. And what I'm left with is x minus 2 equals ln of 7 divided by ln of 2. The last thing to do to solve for x is to add 2. X equals 2 plus ln of 7 divided by ln of 2. All finished. Let's do a couple more examples. Let's solve 3 to the 2x minus 1 equals 5. Again, just like in the last one, there's no way I can write 3 and a 5 with the same base, so I'm going to take any log I want of both sides. And I'm going to kind of go back and forth. And since I took ln of both sides last time, this time I'll take log base 10. Careful to write the log on the left-hand side of whatever I'm taking the log of. The whole point of that is now I can take this exponent that has the x in it and move it in front of the logarithm. So now I have 2x minus 1 times log of 3 equals log of 5. And then to solve for x, I want to get the x out of the parentheses, so I'm going to divide both sides by log 3 so that it cancels. 2x minus 1 equals log 5 divided by log 3. Can add 1 to both sides, so 2x equals 1 plus log 5 divided by log 3. And the final thing to do is divide everything by 2. I'm going to do that as a distributing problem. So the answer will be x equals 1 over 2 plus log 5 divided by 2 and log 3. Let's do a few more examples. Let's solve 5 to the x minus 1 equals 2 to the x. So this one has x's on both sides, and like the previous problems, no way I can write a 5 with a 2 with the base. So let's see, we did ln of both sides and we did log of both sides. Let's go back to ln. So we'll take the ln of both sides of the equation. Again, it really doesn't matter which logarithm you pick. And the whole point of that is to take these exponents, now both of them, and move them in front of the logarithms. That gives us x minus 1 times ln of 5 equals x times ln of 2. I always get questions about parentheses. I put parentheses around the x minus 1 here because it has subtraction. The parentheses can go around the x if you want, but because there's no addition or subtraction, they're not necessary. Okay, now remember, our goal now is to solve for x. Since I have x's on both sides of the equation, not just one side, I'm not going to divide by ln of 5. It would be okay, but it would create a bit of a mess. So instead, I'm going to distribute. And I'm going to write x times ln of 5 minus ln of 5 equals x times ln of 2. Then I'm going to collect everything that has an x onto one side of the equation and everything that doesn't on the other side. So let's see, I could subtract the ln of x ln of 2 to the left-hand side, making it x ln of 5 minus x ln of 2, and adding the ln of 5 to the right-hand side. Now, so moving this term over here and moving this term over here. Now everybody on the left-hand side has an x, so we can treat that like a common factor and factor it out. X times ln of 5 minus ln of 2 equals ln of 5. Now ln of 5 and ln of 2 are just decimals. This is just a constant. We wanted to isolate the x, so we'll divide both sides by those parentheses. Ln of 5 minus ln of 2 on both sides. So our final answer will be x equals ln of 5 divided by ln of 5 minus ln of 2. Let's do another that's similar to that. Here, let's solve 1.4 to the x plus 3 power equals 7. Let's see, whose turn is it? Oh, we're taking just log now of both sides. So let's take log of both sides. Even if I have to smush, I'm writing it to the left of the 7. The entire point of that is now I can take the x plus 3, that's my only exponent, move it in front. So since it has addition, I'm going to write parentheses around it. X plus 3 times log of 1.4 equals log of 7. Fortunately, in this problem, I only have x on this one part, don't have any x's over here, so now I'm going to divide both sides by the log of 1.4. So divide by log 1.4, divide by log of 1.4. So that those cancel. That leaves me x plus 3 equals log 7 divided by log of 1.4. And then finally, subtract 3 from both sides, negative 3 plus log base 7 over log of 1.4. Okay, let's do one more. Let's solve e to the negative x minus 4 equals pi to the 2x. And more than just having e and pi in this example, this problem is really notable because we have an e. So in the previous problems, I was rather randomly picking which logarithm, ln or log base 10, to take of both sides. But since this one has e in it specifically, I am going to take the natural logarithm of both sides because so much cancellation will happen. Okay, the whole point is to move the exponents in front now that we have logarithms. So here's what we have. We have negative x minus 4 times ln of e equals 2x times ln of pi. Now remember, for ln of e, if we work on it over here, this really means log base e of e. That's what ln is short for, is log base e. So the exponent we put on an e to keep it an e is the exponent 1. So this whole expression, and you can verify with your calculator, ln of e is just equal to 1. This whole expression right here is 1. So really what we have is negative x minus 4 times 1 equals 2x times ln of pi. Okay, now remember our goal. We're going to get everything with an x on one side and everything without an x on the other side. So we'll add that x to both sides, making x plus 2x ln pi on the right-hand side and just the negative 4 on the left. And that allows us to factor out that x as a common factor. 1 plus 2 ln pi. And 1 plus 2 times ln of pi is a constant. So it's an ugly one, but it's a constant. So we can divide both sides by those parentheses so that they cancel, and we're left with x equals negative 4 divided by 1 plus 2 times ln of pi.